Welcome to Travel for Engineers, Episode 7. Hi, I'm Paul Heaney, and this is a video series where we discuss the technical side of things that you might encounter when traveling the world. Today, I'm going to talk about elevators. Now, in a typical office or apartment building, we may not think twice about elevators, and they're just functional. But in some fancy hotel lobbies, especially those ones with big atriums, you'll sometimes see glass elevators or elevators structured in such a way that plenty of their working parts are in plain view for the public to marvel at. For example, the last time I was on a cruise ship, it was the Celebrity Solstice, and that ship had a pretty dramatic elevator bank with not only glass walls on the elevators themselves, but just the slick design of the whole lobby made it impossible to miss the cables and the motion control components of the elevators. They were on view plainly for all to see. And let me be clear, this is a win for engineering in my book. We need to do all that we can to make engineering a cool profession so kids will want to know more about it and consider it for their studies. Our own Lisa Eitel covered the mechanics of elevators recently in Design World, and here's some of what I learned in her excellent piece. Modern passenger elevators rely on coordinated mechanical and electronic safety components to detect hazards, shut down equipment, and protect both passengers and technicians. Safety relays, vibration-resistant terminal blocks, and emergency stop devices form a layered protection system whose reliability depends on every link in the control chain. So here's a little deeper look at some of what is inside. Safety relays provide fail-safe electrical control for applications covered by elevator and escalator standards such as EN 81 and EN 115. Their forced guided contacts mechanically link normally open and normally closed contacts, preventing both from closing simultaneously, even if a contact weld or a relay fails. Reliable switching position diagnosis also supports remote monitoring and predictive maintenance by identifying developing faults before they cause downtime. Terminal blocks are critical because elevator wiring experiences continuous vibration and long operating cycles. Screw terminals may loosen over time, threatening circuit integrity. Spring clamp blocks maintain constant conductor pressure, while push-in blocks provide secure, gas-tight connections with faster installation. Push-in designs can reduce wiring time by more than 50% for solid conductors or ferruled flexible wires, require no tools for direct connections, and deliver consistent terminal quality regardless of operator skill. Both technologies are available in multiple configurations and can use self-extinguishing, impact-resistant materials such as polyamide PA66 for durability and fire safety. And then e-stops provide maintenance personnel with deliberate shutdown capacity. Required in locations such as elevator pits and car top inspection stations, they remove power or stop motion during emergencies. Unlike ordinary stop switches, e-stops require a manual reset, typically by twisting, pulling, or using a key, and use a red actuator on a yellow background. Protective shrouds help prevent accidental activation in public or harsh environments. Okay, well, that's it for this episode. If you have an idea for a future episode or would like to be a guest here on Travel for Engineers, please drop me a note at my new email, pheaney@aerofly.com, and let me know what kinds of things you would like to see and have caught your eye while you're traveling. Don't forget to join the Travel for Engineers newsletter on LinkedIn, which was made just for this video series. And please, forward the newsletter to your contacts on LinkedIn who you think would enjoy the series. That's what keeps us growing. Well, keep up the summer travels and keep your eyes and ears peeled for all the cool engineering that is constantly at work behind the scenes. Until next time, thanks for watching.